Hi, and welcome to the lab in Physics 4C. Today is Monday, May the 17th. Okay. So the lab instructions are actually on are on Canvas. So hopefully you guys have had a chance to go through them and see what the instructions are. There is a PDF fillable file in there, and it gives you the link into where you're going to go and do the simulations. So that is basically where we're going to start from today. The lab is due on May 29th, not this Saturday, but the Saturday after, week from this coming Saturday. So it's going to be the last lab. After that, we're going to focus basically on the exam and also on the final. So those are the last two main things that are left in this class. Hopefully you guys take care of that. Obviously, I said in the lecture that we're going to meet also, at least this coming Wednesday. We're going to discuss the problems from this chapter, from chapter 36. And that's going to be basically the main things. I think we probably should meet on Monday, just in case if you guys have any questions or things like that. And there will be no lab this coming Monday because this is the last lab. So there will be no more labs. So, but I think we should meet this Monday, and at least, I mean, this Wednesday, of course, we have to, because we have not finished the problems applications from this chapter 36, but actually Monday, I'm still, I'm going to at least have some stuff for you guys where we discuss things and basically say where we stand and things like that. Okay, anyway, so let me get into the instructions. Let me pull them out. What is the PDF file? And let me make sure I move this one to the front. And let me share the lab instructions. Okay. So again, the PDF file is on Canvas. So hopefully you go through it. And again, in here, it gives a brief history about the wave, I mean, the wave nature of light and things like that, and diffraction and double slit, single slit, the stuff we did in lecture. Again, the straight edge diffraction. Again, in here, we're going to go straight into this simulation. So I'm going to click the link. Once I have the link, let me put it out. And from here, we're going to stop sharing because it gives you the instructions of what to do, okay? So let me see exactly where we're supposed to be and see the properties in here. So I'm going to stop sharing the screen. And I'm going to share with you the actual link, okay? The actual link, of course, has all of these things in here. So I'm going to click on the, I guess I should move this window now here because I'm using the second screen and leave this in here. Okay, so the PHY simulation comes in when you load it. The first part in here, it says go to the diffraction. I'm going to click on the diffraction, double click on it to load. And this is how more or less it looks like. But there are some few things. From the get-go, the wave number is going, the wavelength is going to be 511 nanometer. So leave it as is, okay? Note the scale in here. The scale in here is actually this distance from here to here is 10 nanometers, 10 millimeters, I'm sorry. So you're supposed to be at some point using a, so in other words, that's the equivalent of 1 centimeter. So from here to here is 1 centimeter. So if I have a ruler, and I don't have it with me right now, it's actually on the other side. So I can take a ruler on the screen, because your screen resolution and your screen size might be different than any other screen. But take any ruler and stick to that screen and you can actually measure. There are some screen rulers applications that give you the screen size and all of that, but you don't have to. You can just take a regular ruler and see how much that distance is. And from there, you're going to be measuring some stuff in here related to this lab. So you're going to use your screen in here. So it says in here, make sure the wavelength of the laser is set to 511 nanometer. Choose a square shape for the slit shown. So we're going to change it to square slit, not this circular one. And I'm going to drop the width back to 0.4 nanometers and the height to the maximum in here in this case. So I have chosen all of these properties in here. And in the simulated environment, so once we turn on this thing in here, it says we should see a screen that gives you that the central fringe being almost twice as much as the others, because this is a single slit actually. So if I turn it on, this is exactly what we're looking at. The central fringe is the bright fringe there that you see in the middle. And then one on each side. I see one on each side, 2, 3. So I see 3 times 2, that's 6. Usually the middle fringe, you're not going to focus on it as much, okay? But it's twice as much, and it's very critical in the whole analysis. The dark fringes are the ones that we calculated in the class. These ones, they're given by A, the width, here is the width, 0.04 millimeter, times sine of theta is equal to, A times sine of theta is equal to a number of wavelength times lambda. So this one should be from the center of the fringe as by being 1 times lambda times divided by A. So the arc sine of this number. In here should be 2 lambda divided by A. That is the arc sine of this guy to give you the actual direction. And so on. This one is 3, and this one that probably is in here also is 4. Okay. So 4 dark fringes on one side and 4 on the other side. That's for a total of 8 dark fringes. But there are 7 bright fringes altogether, 3 on each side, plus the central bright fringe, okay, which is typically twice as much. So you see this pattern, you know that you're dealing with a single slit, okay? And here it is. Here is where the opening is. So from the top in here, you can clearly see what we're looking at. If we did this experiment, this is exactly how it's going to look like. In the lab, we control the distance from the central fringe, from the fringe itself, to where the screen is. And this is the source in here. The laser source is usually very close from here, from the power source. It's actually usually it's one device in there. And there is a dial that you change the size and so on and so forth, okay? So I'm going through the instructions. By changing the width of the narrower slit separation, will the diffraction pattern also get wider or will it get narrower? So by making it wider, what happened to the pattern? That's all you're supposed to ask here. Will the diffraction pattern get wider or will it get narrower? You can clearly see that the bright fringes get narrower and there will be more and more dark fringes enclosed. So that was question 1. Question 2, set the width of the slit to 0.04 millimeter, just like it is right now. This is 0.04 millimeter. You can clearly see the reading in here. And its height to about 0.4. There is a typo in there. It's not 0.40, it's 0.40. About the way it is right now, okay? Change the color of the laser from the 511 nanometer to 529 nanometer. What are the differences between the 2 different patterns? Think in terms of intensity, size, and number of bright and dark fringes. So we're going to change the frequency to 529. This is 529, somewhere in 629, sorry. 620. When you are around it, you can use the typically, when the lasers are given, they give you their frequencies already, okay? So you can't really play around too much with their, so this is the red light, but the frequency on this one, I forgot which was, but it's some 640 nanometer, I think. This is the green light, okay? So now we changed it. Look at the pattern now and compare it. You can take a picture of them and and compare the 2. From the 629, I have 1 dark fringe, 2 dark fringes, and possibly a 3rd dark fringe in here. Whereas in 511, I had probably more. Okay, I had 1, 2, 3, and 4. Okay, but look at the width also of the red versus the green. Okay, the width of the central versus the width of everything that's in here. Okay, so it's a good idea to take probably a picture so that you know what is 629. I lost it. Okay, 629. So this is basically the comparison, the next one. So that's the next question. Now turn to the disk to a wider slit, 0.1. So we're going to put it 0.1 millimeter, the way it is right now, okay? And keep its height at 0.40 millimeter, the way it is right now. The screen at a distance L 90 centimeters. This distance is 90 centimeters from the screen to where the fringe is, okay? To where where the slit is, okay? That is 90 centimeters. And for the green light, so we need to go back to 511. This is 511 nanometer. Measure the vertical distance from the dark fringes, m equals to -4, for example, to the corresponding dark fringe on the other side of the central peak, for example, m equals to +4, divide by 2m to get the value of y and enter it in the expression, okay? And once you do that, you're going to come back into the other table and fill it out. Let me explain what we're talking about in here. So we have this distances in here, and we're going to pick up two values in here. We're going to pick up a number. It doesn't matter which number you have. Remember that rule I said in the beginning about the distance in here being 10 millimeters? So take your ruler, and you have to have a physical ruler in here, and measure this distance, and now you know the scale. Let's say, for example, this is 1.5 centimeters on your scale. This is 1.5 centimeters, then this distance in here should scale correctly, okay? Use that as your ruler now. So if this is 10 millimeters on your scale, see how many is there in here so that you're going to convert it into the proper units, okay? Because your screen might be smaller or bigger depending on its resolution, depending on the size you put it in. So that's why the scale is given in here to you so that you compare apples to apples, so that you know what is the distance from, you want to know the y, okay? The y value. So what you do in this case, you take any point. Let's say we take 1, 2, 3, 4. This is the 4. So if I take this point in here from here and mark it in here, so I have a marking in here, and then I go put the ruler in here. So I put the end of the ruler, 1, 2, 3, and 4. Put the ruler in here and move the other side to 1, 2, 3, and 4. Okay. Measure this length in here in centimeters or millimeters, because this whole thing is in millimeters. So measure the whole length in millimeter and divide it by, in this case, because I took m equals to 4, divided by 8. Correct? If I took 2, for example, which is 1, 2, and this is 1, 2, and so this whole distance in here from here to here divided by 4, okay, and so on and so forth. If I took instead 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, so I have 10 on either side and 10 on the other side. Measure from edge to edge, that's going to be 20. I mean, divide by 20 at the end. Whatever I find in here divided by 20. Remember, this distance is 10 millimeters. So whatever I find in here needs to be scaled according to this distance. And from there, I have a distance in millimeters. Now I have to divide it by 20 milliliters. It's by 20 in this case, depending on how many I take. Okay, so I'm going to leave it to you guys which number you take. Okay, I mentioned the instruction 4, but you could take a different number other than 4 depending on what you have available in there. So, and then divide by 2m. Repeat this process for another value of a, for the red laser. So now we're going to go back into the table. If you look at the table, we're going to change the a value from 10. Right now it's at 10. We want to make it 0.8. Right now it's 0.8. So you're going to do the measurements again. You have to be very careful with the measurements because you will probably find no difference between the two. Okay. So you have to be very careful between 10 and 0.08. You have to really be precise in your measurements. You see, it's a very subtle difference between the two. Here is a 10. Here is the 0.08. Okay. Now do the measurements again. 1, 2, 3, 4, 5, 6, 7, 8 now. We dropped by 2. Okay. So it's going to be by 16 now. Okay. So now you have a measurement in it. Don't take the edges, okay, because there might be bigger than what they are or smaller. Just take in here, for example, in this case, stop in here if you really want to make the long one. So you have two values. Now redo the whole thing for 629. So we're going to do the same thing for 629 now, for the red light, basically. Oh, here is 629. Obviously, 629, I cannot go all the way to the edge because the whole thing starts to darken, so probably I can just take this number. So this is 0.08. Remember, I'm doing it for 0.08, and then, although that's the last one in the table, then we're going to do the 0.10, do the same calculation. Does this make sense to you guys? Yes? Okay, very good. Thank you. Now, question 3. Did you find one slit easier or harder to do over the other? Why would this be the case? That depends on lambda. Okay, that's going to be very helpful or not. So how A and lambda differ from one another. Did you find one closer, one color laser easier or harder to do over the other? Why would this be the case? Again, think in terms of how A over lambda is working in this case, okay? Because you have lambda and you have A in millimeters. Now change the slit to a circular slit of diameter 0.04. So we're going to click in here to change it to a circular slit. This is how it's going to be. And make sure the diameter is 0.04. So we're going to go back to 0.04 here, the diameter, okay? And it didn't say anything about the eccentricity, but leave the eccentricity low, okay? Don't make it oval or anything like that. Don't make it like this, okay? Leave it open, because look at the shape of the slit. So don't change it. Keep it oval, basically, which is like a circle. Now measure the distance to the first dark ring by measuring the entire diameter of the first dark ring and dividing by 2. So basically, we need to find this distance from here to the first dark ring. So what you do in this case, you take your ruler again, don't forget the scale in here, and measure the entire diameter and divide by 2. That is how much the radius is going to be, okay? That is how much the distance is going to be. The value obtained for divided by L, so you take that value and you divide it by L. Don't forget that I think I didn't use L in there, I used R. Here's L. So the first one, there is a formula, lambda equals to AY over L. That's used for the first table, so that's good. And now we have to find theta, okay? In order to find theta, you take this radius in here, and you divide it by L. L is given to be 90 centimeters. It's the same value as before, so it did not change. This distance from here to here, it's 90 centimeters, about almost a meter, okay? So you're going to use that value from before. And now you're going to find theta. Theta is just the arctangent of that ratio. But again, since the distance is going to be very small, distance is going to be very small, divided by 90 centimeters is going to be very small, divided by 900 millimeters, by the way, because this is already in millimeters. So whatever you find in here, you have to divide it by 900. That is going to be theta 1. That is going to be the first dark ring in here, okay? The formula for the dark rings in here, this is called the Rayleigh condition, is the tangent for, or the sine for that angle is given as being 1.22 times lambda over d. Okay, the derivation for it is quite involved, so just take it as a value in here for the Rayleigh scattering. And that is actually how we define determine the resolution of a device. Also, we use Rayleigh scattering, okay? Calculate the error. So in this case, there will be discrepancy, okay? You know what lambda is. You know lambda is supposed to be 629. We're supposed to go back to 511, I'm sorry. We should really do 511 in here. If you want to do both of them, since you know what lambda is, since you know what d is, Hence, the formula is supposed to give you 1.22 times lambda over d. That should be your angle, because sine theta is very close from theta is close from tangent theta. However, if you use the formula, which is the ring itself radius divided by L, that should also give you the value of theta 1. So you have two ways of finding theta 1. One way is finding it using the formula, which is 1.22 lambda over d, and you have lambda, in this case is 511 nanometer, divided by d, and d is 0.04 millimeter. So that is one way of finding it. Don't forget the 1.22. So that is one way. The other way is just taking this radius r and divided by 90 centimeters. Okay, you need to tell me if the two results are the same or there is a discrepancy between them. That's one thing. Then you change it to the other color, 629, and you do the same calculation. And you tell me if there is an agreement between the experimental value, the one that you measure, and the known value, the one that comes from the other formula. Make sense for question 4? Okay, very good. So the double slit now. For the double slit, what we do in this case, we're simply going to switch to the other one. For the double slit, I'm going to see in the bottom in here, you can click on slits instead of slit. And from the get-go, you need to look at the picture and see what you have in here. First of all, we need the ruler, okay? To measure things. For this part, we have a ruler, which is easy, okay? We don't have to worry about things, okay? And we're going to change it to a light source, okay? That's one thing. And we're going to select screen, okay? And we're going to go to the width to be about 300 nanometers. Before we do that, we want 2 slits, okay? And the width of each one of them is 300 nanometer, and the separation to be about 1600 nanometer. So the separation to be this 1600 nanometer. Basically, this is D, and this is A. A is this distance, and D is this whole distance between slit and slit. Okay, so we're set up now. We're ready for the actual instructions. They tell you in here, use this value as being 2500 nanometers. So in other words, this is the distance I'm looking at. It's because this center is somewhere in here actually. So it's about 2500, okay? You don't need to measure it, okay? Just assume, as long as you don't move things around. If you move things, this becomes an issue, okay? If you move, because you could theoretically move the screen in here. So I don't want you guys to move the screen, leave it as is, okay? Don't change it too much, okay? Now, having that distance, now we're ready. Choose the ruler for measurements. Your screen should look like this, okay? It tells you this is how the screen should look like. You don't need this for it now. Just take it out, move it closer to close it if you like, okay? There is no harm in this. Now, it tells you how the pattern should look like. Actually, if you look at it, there is a grouping. There is a central group, which corresponds to m equals to 1 for the double slit, for the single slit, and in it, there is a double slit, okay? This is a typical picture, actually. If we did this lab live, you would see this picture actually there. Okay. Now turn to the wider, to a wider of A equals to 400 nanometers and D to be 200 nanometers. The distance from the slit. Oh, I'm sorry, it's supposed to be 2000. Okay, there's a typo there, okay? So please fix this number. Let me stop sharing the screen and tell you where the stop. Share. This is supposed to be 2000, not 200. Okay, it doesn't make sense to have the distance less than the slit size. Okay, so Where is the edit text, edit PDF? So please fix this number, okay? This is supposed to be 2000. So this number is supposed to be 2000, and this formula now is messed up. This whole table is messed up. Can I make it bigger? I'm going to assume that you guys are going to fix this number in here, okay? So it's very important that you fix that. Otherwise, you're going to get some nonsense. So everything should be the same. Measure the vertical distance from the dark fringe to another dark fringe, counting the number of them n, divide by n to get the value of y, and enter it in. This is similar to before. So we're going to use this formula to find everything now. So dy over L, that should give me lambda. So where D is 2000 nanometers, not 200 nanometers. If you do it, you're going to get big errors, big time. And Y is the measured value divided by L, and L is 2500 nanometers. That should give you the wavelength lambda, okay? And the wavelength lambda of the signal that you have in here. So here are the values in here. So A, I need to fix these instructions. There is some issues with them, okay? So A, here is the value. It's 2000, correct? 2000, correct, and 1600, correct. And you're supposed to use the green light, okay? So let me stop sharing, and let me share with you. Share with you this one in here. So here is the deal. Keep this distance from here to here, from the slits to the screen, about 2500 nanometers. And keep the distance in the table to tell you to go from 200. So we're going to do the 200 first. And we're going to leave it at 1600 in here. So we're going to turn on the power, and it looks slow. It should not really be slow. I know it says normal, but this is not normal, okay? And it tells you to use the ruler to find the distance from the slit of the screen, measure the vertical distance from one of the dark fringes to another dark fringe. So we're going to find in here one of the dark fringes, let's say this one. Actually, we need to move this one first in here. And this is the one that I'm supposed to find. So the distance is 2,700 and somewhere in the middle, okay? 2,790.6 nanometers. So that is the distance Y. And I have D to be 1600 nanometers in this case, to be 1600 nanometers. And I have L to be 2500 nanometers. L is actually equal to 2500 now. From here, I can find what lambda is. Use the formula that was given to you. Now I need to do the same thing, but change now the value of L actually, or this number to 2000. So I'm going to change this number to 2000. Now it's 2000, and the dark fringes actually have moved slightly. So I really need to change this measurement in here. So now I have, but don't forget to divide by 3, okay? Because I'm sorry, divide by 1, 2, 3, and 4. Divide by 4 in my case. I took m equals to 2 in this case. Okay, so I have to divide by 4 to find y. So it's not this whole thing divided by 1. It's 2,211.4 divided by 4. So I forgot to say that earlier for the previous one. So that's going to give you the y. So it's going to be about 500 basically. 550 probably, 550 something nanometers. You multiply that by D, and D in this case is this distance, okay, which is 2000 nanometers, and you divide by L, which is 2500 nanometers. So you did both parts now. Now we need to change the distance to 300 according to the table. So we need to make it 300 and do similar measurements. And here I have to be careful in here. So I wait for it to first of all get into focus, move this one closer a little bit, and this one, try to put it in the middle, okay? So it's gonna matter a lot. So now I have also n equal to 1, 2, 3, and 4. So it's still 4. So this distance divided by 4, this should be 500 and what? 520, around 520, 21 nanometer. Again, multiplied by D, and D is in this case 2000. divided by A, and in this case, A is 300 nanometers. Okay, there is the A is not in the formula. I'm sorry. dy divided by L. L is actually 2500 nanometers. Did not change. Okay, and then I need to change now. The last part of the table is to change this value back to 1600 and keep the value of the width to 300 nanometers, and make sure I refine my movement in here, move this one up here and this one in there. So it's 2,732.5 nanometers divided by 4 again, because I'm counting how many dark fringes I have. 1, 2, 3, 4. And that should give me Y. Y times D, and D is in this case equal to 1600 nanometers. Divided by L, and L is 2500 nanometers. That should give me the values of lambda that I'm using in here. Try to find the average of all of these values. There should be your lambda. And does it make sense to you? Is this in the green range? Is this color acceptable? It should be around 500 nanometers if it is acceptable, okay? So that's question 5. And the last question, question 6, is actually a general question about the difference between the single slit and the double slit, especially in terms of the patterns. You can clearly see the patterns in here versus the previous ones. And that's it. That's all the lab in here. And that's after that, there is a conclusion and we're done with it. Easy enough, isn't it? Yes? Okay, very good. So again, and we're done with lab. So hopefully you guys will finish this one, have fun with it. And then let's do the 29th. I'm gonna post this recording shortly after this meeting in here. And I will see you guys on Wednesday for the lecture, where we do problems actually on this Wednesday. Good? Okay, thank you, you too. So I'm gonna stop recording.